When we are using function notation to solve for x, that means we are being given the value of the output of the function f of x, and we are asked to use the function rule to work backwards to solve for the input x. So in our last toolkit, we were given the value of the input x, and we plugged that into the function rule for x to find the output f of x. Now we're doing the opposite. We're being given the value of the output, m of x, and we're being asked to replace the output in the function rule with that number and then to solve for x. So in this case, m of x, my function rule, equals 2x minus 3, and I'm being told my output is 15. So I replace m of x with 15, and I know that 15 equals 2x minus 3, and I just use inverse operations, adding 3 to both sides and then dividing both sides by 2 to find that my input is 9. So this is a perfectly fine final answer. X equals 9. I was asked to find x, and x is 9. I can also write the entire statement, m of 9 equals 15, and that is a very complete answer because it tells me a lot of information. It tells me that given an input of 9, my function m gives me an output of 15. Let's go ahead and check that that's true. Input of 9, 2 times 9 is 18, minus 3 is 15. Yep. Given an input of 9, my function rule m, or my function m, gives me an output of 15. Here's a couple more examples. Given a function w, my function rule w of x is 3x minus 6. Now here's my question. If w of x equals 24, what is x? Let's find x. So what I'm going to do here is I'm going to plug 24 in for w of x. My output is 24. 24 equals 3x minus 6. And now I just need to solve for x using inverse operations. Let's add 6 to both sides. And then let's divide both sides by 3. This is an a-okay place to stop. My input is 10. So if I plug 10 in for x, 3 times 10 is 30, minus 6 is 24. That gives me an output of 24, and that is true. That is correct. I can also write the entire statement, w of 10 equals 24, and that gives me more information. Given an input of 10, my function w gives me an output of 24. So final answer, w of 10 equals 24, or just x equals 10. Another function rule here, my input isn't x, my input is n. That's fine. My output is g of n. So let's plug in negative 35 for my output, g of n. Negative 35 equals 2n minus 5. Inverse operations. Let's add 5 to both sides. Divide both sides by 2. And my answer is not x equals negative 15, but n equals negative 15, because here I'm using the variable n for my input. So final answer, n equals negative 15, or the complete statement that gives me both pieces of information, g of negative 15 equals negative 35. Given an input of negative 15, my function g gives me an output of negative 35. Let's go ahead and check that that's correct. 2 times negative 15 is negative 30. Minus 5 is, in fact, negative 35. Great. Let's go ahead and look at this old toolkit from our function or from our linear unit. What we're doing here is the same as what we were doing in the bottom half of that toolkit. Here we were given the value of y, and we were plugging it in for y and solving for x. That's exactly what we're doing here, except instead of being told y equals 27, here we would be told f of x equals 27. We would plug 27 in for our output and then solve for x. Really, the challenge of this particular skill, function notation with equations, is figuring out, am I being given x or am I being given the output f of x? If I'm being given the input x, I will be asked something like find x or f of 3, and that means x equals 3. If I'm being given the output, I'll be told to find x given f of x equals to a number. Let's say f of x equals 10. So the challenge really is figuring out, am I given x and I'm being asked to find y, that would be like this, number in the parentheses. Or am I being given the output, y or f of x, and I'm being asked to find x?